Hello bachcho, let's read the question. So the question says diffraction of light. The diffraction of light takes place when an object or obstacle comes in the path of light. In this phenomena, bending of light takes place around the edges of the obstacle. The bending of light from its path is larger when the size of obstacle is comparable to the wavelength of light. If we place a narrow slit in the path of wavefront of light, then bending of diffracted wavefront will be more. The diffraction of sound waves also takes place. For visible light, diffraction can happen when an object of lambda comparable to 10 to the power minus 6 meter order comes in its path. The diffraction of light waves increases as the size of aperture of the hole. Now we have to say about the aperture of hole or D in this diagram. So we have to say that if D decreases, increases both A and B or remains same. Okay, so now let us first revise the key concept behind this question. So the first key concept behind this question is Young's double slit experiment. The second key concept is on which the Young's double slit experiment is based is interference. And on the phenomena on which interference is dependent is diffraction. The main concept is diffraction in this question. So what is diffraction? Diffraction is the phenomena of bending of light when a object or obstacle of the size comparable to the wavelength of the incident light comes in the path of light, and hence the here the light bends around its edges, or the edges become a secondary source of wavefront, and hence there we can observe, if we take a small slit and a screen, we can observe a white spot here, bright spot. Okay, so and this is our source, let's see. Now what is interference? Interference is when two waves, due to wave nature of light, when two waves of light interfere with each other to form destructive and constructive part together, they are called destructive interference and constructive interference. And Young's double slit experiment is based on both of these topics, in which when we place two slits as shown here, we can see that the two slits form form a central white spot at the center, and there are fringes of white spot around it with equal distance, and this is called Young's double slit experiment. Now what does the question asks us? It asks that the diffraction of light waves increase as the size of aperture hole. So what do we do to this D in order to increase the diffraction, the order of diffraction? Okay, so if the D increases, what happens if D increases? That we are given with broader slit here. So in this case, D is increased, and hence lower amount of light bends around the edges, and hence diffraction is lesser. While in the second case, it is purely theoretical, or we can observe it purely that when the two edges of the slit are closer to each other, we have a narrow slit, and in this case the light has more area or more amount to scatter or bend around the edges, and hence diffraction is much more, and hence we can mark our solution directly, that option C, in which when D decreases or aperture decreases, we have the diffraction increases, and option C is the correct option to this solution. I hope you understood it well. Thank you.